Hello everyone, welcome back to my YouTube channel. Myself Varshin. Currently I'm pursuing the in Sri Venkateshwara College of Engineering. Today I'm here to present computer graphics and visualization. In that, so today's agenda is to cover about 2D pipeline, 3D pipeline, RGB and CMY color model. So coming to the 2D pipeline. So basically, what is 2D pipeline? So it is a section of a two-dimensional scene that is selected for the display that is called a clipping window. That is, see, in the picture, you want only the dimensional scene. In that, we need to select the display that is called a clipping window. Sometimes the clipping window is allotted to the word as the viewing window or word window. The deep flipping window is also known as word window or viewing window. So graphic packages allows us to do control the placement within the display window using another window called the viewport. So as you can see in the picture, so as we have already said, what is 2D pipeline? So in this picture, you can see here there is X coordinate and Y coordinate. Here the clipping part is this, that is the clipping window. So clipping window, it tells us about what we want to see. And the viewport, it indicates that where it has to be viewed on the output device. That is, clipping window says what we have to be viewed. Viewport says on the output device where it has to be seen. So that is as you can see in this picture. So what is viewing 2D pipeline? So the mapping of a 2D dimensional, that is word coordinate scene description to device coordinate, is called a two-dimensional viewing transformation. So as you can see in this picture, first from the MC, that is mapping coordinate, we will construct the word coordinate scene using modeling coordinate transformation that is converted into word coordinate. So again, the word coordinate has been converted into viewing coordinate. Again, we will transform viewing coordinates to normalized coordinates. So the normalized coordinates again it will be mapped to device coordinates. So at that time, we will get the 2D pipeline. So usually, we can describe the steps as seen in the figure. So once a word coordinate scene has been constructed, we can set up a separate two-dimensional viewing coordinate reference frame for the clipping window. So to make the viewing process independent of the requirement of any output device, graphic systems convert object descriptions to normalized coordinates and apply the clipping routing. So the system views normalized coordinate range that is from -1 to 1. So at the final step of the viewing transformation, the contents of the viewport are transferred to the positions within the display window. So this allows us to reduce the computation first by concatenating the various transformation matrices. Coming to the 3D pipeline. So what is 3D pipeline? So 3D pipeline is to obtain a display of a three-dimensional word coordinate scene. So we first set up a coordinate reference for the viewing or camera parameters. So this coordinate reference defines the position and orientation for a view plane or projection plane that corresponds to a camera film plane. So it constructs the shape of an individual object in a scene within modeling coordinates and it places the objects into appropriate positions within the scene. So converting the viewing coordinate description of the scene to coordinate position on the projection plane is called 3D viewing pipeline. So as you can see in the picture, so first we need to construct the modeling transformation that is mapping coordinate, then to word coordinate, then we will convert this word coordinate to view coordinate by viewing transformation. Again, we will convert this into project coordinate, that is projection transformation. Then projection transformation to normalized coordinate by the clipping method, and normalized coordinate finally converted into device coordinates using viewport transformation. So here, word coordinate positions are converted into viewing coordinates. So MC means modeling coordinates, WC means word coordinates, VC means viewing coordinates, TC projection coordinates, NC normalized coordinates, TC device coordinates. So a two-dimensional clipping window corresponds to a selected camera lens is defined on the projection plane, and a three-dimensional clipping region is established. So the clipping region which is established is called the view volume. So objects are mapped to normalized coordinates, and all parts of the scene outside the volume have been clipped off. So the clipping operations can be applied for all device independent coordinate transformation. So the final step is to view map, that is viewport coordinates. We need to map viewport coordinates to device coordinates within a selected display window. So this is about 3D pipeline. Next topic is RGB color model. So RGB color model, it consists of three primary colors, that is red, green and blue. So according to the stimulus theory of vision, our eyes perceive color through the simulation of three visual pigments in the cones of the retina. So the three primary colors, as we know, it is red, green and blue, which is referred as the RGB color model. So as you can see in this picture, it consists of red, green, that is RGB, and it consists of other colors like CMY, cyan, magenta and yellow. It also consists of other colors like white, black. So the origin represents the black, and diagonally opposite vertex, that is the white coordinate, it is represented by the coordinate axis 1, 1. So the formula is C of G equal to RGB, that is R plus CP plus VP, where the parameters R, G and B are assigned to the values in the range from 0 to 1.0. So each primary color can take an intensity value ranging from 0 to 1, that is from lowest to highest. So mixing of these primary colors at different intensity levels will produce a variety of colors. That is CMY color model. Next topic is CMY color model. That is CMY. It is a subtractive color model that can be formed with the help of primary colors like R, G and G. So we can form CMY, that is cyan, magenta and yellow. As you can see in the picture, it's a cube that represents the CMY color model. So it is a secondary colors of light and primary colors of pigments. That is, if white light is shined on a surface coated with cyan pigment, no red light is reflected from it. So here, the origin represents the white light, and equal amounts of each of the primary colors produce shades of gray along the main diagonal of the cube. So a combination of cyan and magenta is, it produces the blue light. Red and green components of the incident light are being absorbed. Similarly, a combination of cyan and yellow ink produces green light, and a combination of magenta and yellow ink yields red light. So CMY printing process often uses a collection of 4 ink dots, which are generally arranged in a closed pattern, somewhat as an RGB monitor uses 3 phosphorus dots. So in the practice, CMY color models has been referred to as CMYK model, where K represents the black color parameter. So as you can see, as we can compare RGB color model and CMY color model, in the coordinate there, we have G 1, 1, these coordinate axis value for white, but here we will give 1, 1 for the black coordinate axis. So this is about CMY color model. Thank you.